So my name is Girish Kumar BK. So I'm the SNIA technical member here in India, and I work in NetApp. So there was a good talk today from Steven on the SODA and talking about data autonomy, right? So this talk is about why do we think about all these things, going for the data autonomy, what's happening, what has changed over a period of time. Data management or data management challenges, it's a pretty old topic, right? But there are so many new applications have come which needs for us to rethink over what we were doing earlier and what's needed in the future, right? And I have a simple 4-point agenda, which is I'll talk about the data growth that's coming up due to various new applications. A lot of things have changed across different verticals. They all come together, enable new applications for end users, trying to reduce their the challenges that they face and increase the quality of experience for them. So all this is happening across many industries. So now it's time for us to rethink over what are the new applications that we enable and why we are thinking about this. So in that context, I'll talk about the traditional data management, what we used to think, and what are the new data management techniques that people should be aware of or are thinking in that world, and why it makes sense now, right? And then I'll give a context about OpenSDS that Steven talked as to how it is relevant in this forum, and give some insights into how it is related to SNIA and what SNIA is doing about it, all those related information. Then I'll have some closing thoughts to brief about this. Okay. Hope I will after the end of this talk, maybe it's a very short talk, but I will invoke some thoughts within you as to whether does it really make sense and why we should be here, right, in this open source forum, right? Okay, so before giving a brief about why it makes sense, so I would like to talk about some of these trends, right? These are the trends that are driving new applications, all right, and why there is so much of talk about all these things. So first, 5G and IoT. So everybody knows about this. We are going through this move from 2G, 3G, 4G to 5G and 5G plus. It's a new infrastructure that is coming in. So to give you context, there was a game called Pokemon Go, right? Anybody played that game? Just show your hands, right? When it was released 3.5 years back, if anybody would have played that, you would have realized how the awful the network was in some areas, right? Only few people who had a very good broadband connectivity or the wireless connectivity could play that game very well. It's augmented reality gaming, right? The augmented reality is something different from virtual reality, right? Virtual reality takes you to a totally different world which you have not seen at all. But whereas augmented reality will bring any virtual world to your physical world. That's right. And that's what the Pokemon Go did. In your real world, you had Pokemons going around everywhere, and you should go and just catch it. And it's a location based. And in the background, when your avatar in the Pokemon Go was moving around, it's actually in your real world. The data from wherever you are standing or moving around, that video data went to the local servers. From there, the backend compute created a augmented reality for you back and again placed it onto your mobile phones. So all this should happen in the background within split of time, right? So that's a kind of applications. Pokemon Go came in a little bit earlier, but now with the 5G, with the high bandwidth and the low latency, all these applications will become a cool stuff, right? And IoT, talking about IoT, we know it's a most buzzword nowadays, but things can be like as good as your watch, or all the way up to your big car, autonomous vehicle, self-driving car. But now if you see the form factor of IoT things that we are talking, it's a huge, right? From your watch to all the way up to self-driving car. It's a different form, different compute requirement, different data. The data that grows is totally different, but it's a wide scale that we are talking here. And no single solution can fit all these use cases in one form, right? So it's a wide scale that we are talking here. And then these are some of the applications like augmented reality, virtual reality, video surveillance for all the security applications like in the border. You're monitoring so many things for intrusion detection or a pattern detection, all those things. So video surveillance has been there, and it generates a lot of video. And self-driving vehicles, they generate a lot of data, video image data, the LiDAR data, so many things. So all these are examples of new applications that are being enabled by this new infrastructure. And of course, the IoT talk is not complete without the smart factory. So any optimization that happens within your factory with the optimizing your working lanes, so that's the talk about that. And all these things are happening. Why the companies are bothered about getting artificial intelligence or a machine learning technique, right? They want to get the business insights from all that data that enables them to operate better, right? And that's the key. New applications, you have to gather the data from multiple sources and crunch them, get the business insights, and then give it back within a certain period of time. And and these applications are creating very data intensive workloads, time series, 4K, 8K video image, LiDAR, radar. Time series, some people might think it's still small, but if you think of Boeing engine generating, which has got almost around 10,000 sensors, if it generates every second one value, it's a huge data. A single flight can generate terabytes of data, right? How do you take it to the servers to work on that? So that's a scale here. And now we have the edge and the cloud computing. We had the cloud computing. We talk about edge because we can't send all the data to the cloud. We are swinging between this architecture of client server, and then again we are saying it's a centralized. Now we are coming back again and saying it's a distributed edge. We are swinging between this architectures, right? But that's basically because the SLAs, the expectations from the applications are changing always, right? And then the compliance and governance. Since we are talking about data, without talking about privacy and security, it's not complete. And then the data sovereignty is one of the key things that any corporate should be aware of, right? So just to give you some examples, so here I have mentioned some smart factory, how much data it can create. Like it's almost like 5 petabyte of video data that it can create. It's typically an example where, let's say that a factory which wants to enforce certain compliance rules, and if there is a violation, how do you detect that? Basically, drones going around all the ends of factory, trying to monitor if there is a compliance violation. Today, it might be done with few video screens and a person sitting there. But if you have to scale it to some, let's say 32 video cameras or 64 cameras, it has to be done by machines, right? It's not just possible for a human being to monitor so many videos and try to assess that whether there is a compliance violation, right? So a lot of data and self-driving. I know this is a very popular topic, but that's a kind of data, 4 terabytes per day. It's almost like 4 is a very rough estimate, but it can be around 10 terabytes also, depending upon where the vehicle is being driven. And it's estimated that there will be more such vehicles going around in the future, right? And when we talk about all these things, if you are a person from storage or generally, if you are bothered about how do I manage my data, so immediately you will ask these questions. How do I aggregate such a high volume of data, right? What's the technology that I should have? And how do they come to me? And all these interfaces, different protocols, it's so many questions will be arising, right? How do I manage this data? And how do I deploy and scale any kind of edge infrastructure that I need to have? let's say this is quite well known, right, that everything cannot go to the cloud. Some things will have to be processed at the edge because of the latency sensitive applications, right? The latency is the driving factor for it to be processed at the edge. And then you start asking, how do I scale? Let's say that in this forum, we are around some, let's say 200 people, but suddenly there are 1,000 people, all doing using some mobile applications. So much of data is suddenly growing, right? It's elastic. So you need to have an elastic scale at instantaneous of a time, right? That's a question. And it's not just about one type of data. It's just video, it could be images, it could be LiDAR data, it could be radar data, any kind of data which is coming into you. And you should be able to understand those data. How do you put them into the right data store at the right cost, right? And again, the last one is because how do I start from small and then increase as I grow? And all these things, if you just wonder, then the need that arises is we need a kind of a scalable architecture, right? Which is kind of standardized, right? Like so many applications, so many form factors, so many data formats. If you try to answer all these questions with the different software stacks, you will end up doing so many projects, right? So you need a kind of a standardization for that. Some level of understanding as to this is my API, this is the boundary that I'll draw, and then go forward from there. And everybody agrees that this is what we will all do. And anybody can connect to that. So that's the kind of thing. Okay, and now quickly, I'll just talk about the data management challenges when you think in this context, right? See, for any machine learning workload, right, I hope some of the data scientists are here, or you know that a bad quality data, if it enters into your machine learning system, what havoc it will create, right? When I say bad quality means it's not the right data. When we talk about data quality, when let's say a temperature sensor, if it generates what's the ambient temperature in this room, but at some point of time it starts creating outliers, 99 degrees in Bangalore. That's something unheard, right? But if that outlier, that data goes into your modeling, then you know what the result would be. So bad quality data could be it could be with respect to the accuracy of data, the completeness as in the data is coming all the time. It's not generating just the zeros all the time, and conformity to what standard in which the data has to be created, and consistency. It is consistently generating the right data, the accurate data that you would like to have. And quality is also about the kind of data that you would like to have for your model trainings, right? It's both the normal, what you say, the normal operations data, then the exceptions that it creates, all that mix of both of data, then only your training would be complete, all right? And then these are some of the challenges. Why I would say is that because today's data science or the data engineer, right, they almost spend 70 to 80% of the time on this itself. Before even they start training their workload, they spend a lot of time on preparing the data. So this is kind of a new generation data management problem, right? It's not there earlier, but it's there now. If a data engineer is spending 80% of the time, then it's too much to, they're spending a lot of time on this, right? You can't ignore that. Then data capacity management. So all these data workloads that I showed you, these are new workloads. It's pretty hard to get any traditional data reduction in this world because they are noisy. They're completely noisy. Traditional dedupe doesn't even work there. And if you rely on any standard compression techniques beyond the theoretical limits, you wouldn't get much of the reduction. But having understood the application that runs behind this, like any data science flow, you know that noise can be taken away. So you need to think about all these new techniques, which is data filtering, intelligent data discarding, right? The data that you don't need, you can always discard. But you need, when I say intelligent means it's application aware, right? You know that the application doesn't need that data means it's almost like redundant for you, right? And then data privacy and security that I talked earlier, sensitivity, data masking, the data that you think that it's sensitive for a certain organization, you can mask that data before it is being sent. And then privacy preservation encryptions, when you send the data to the cloud, you can always, you have techniques to encrypt the data on which the analytics can be done without decrypting the data, right? And that's a call here that you need to think a little bit higher on the data level management. So some of the examples here, hope now it gives a better context for you people, what I'm talking about. The top one is the time series data. So this is a data from a vehicle speed across taken over a period of time. This says how the speed of the vehicle varies over a period of time. As you see this graph, this is so varying, right? You can hardly think of reducing this with the standard techniques, right? Compression techniques. You can compress it, but it has so much of noise that you will get, it's very hard to get beyond certain limit, right? And this is a video image of a self-driving car that's coming from different vehicles. There are some data sources like a surveillance camera, oil and gas. And the top one on the right-hand side is the LiDAR data. So LiDAR is being used by most of the self-driving cars today. And LiDAR data is nothing but the XYZ coordinates in your environment, and that's what it is capturing. And with the color data, it becomes a four-dimensional. It's a three-dimensional, and including color, it becomes four-dimensional, and then that's the data and it's very data intensive. And all these new workloads are generating the data. Okay, so all this talk leads to some of these questions, and we think that when we say data management, we need the ability to ingest and store this data at a scale. At a scale as in you should be able to scale quickly as the data growth increases, you should be able to scale, right? Now, when you talk about all these things, do you think that it's possible to do with the physical data stores? It's hard, right? That's where you start thinking, can I have a software-defined storage provisioning, right? As the data grows, I should be able to deploy my provisioning of my software through some automated scripts, right? We should be able to kick in. That's the model here. Aggregate this data and retain that data for a certain period of time, right? And move the data wherever required. So a data collected at one place could be required by data scientists sitting at some other place, but you should know how to move them effectively. Enable any orchestration as you saw in the SODA platform, right? You want to enable compute on those data. So you should be able to enable those orchestrations that can happen on the data by providing right access methods, right? So you have the data, you have the compute, unless you connect them both together with the software objects, right? They're not going to talk to each other, right? So that's where you have the world of Kubernetes and then the dynamic provisioning and giving access to the data. And this avoiding vendor lock-in, this is more of enabling the customers to a choice, right? It's more of enabling the choice, right? When we say avoiding the vendor lock-in, I started with one workload. I figured out that this is the right thing for me, and over a period of time, I realized that this data could be analyzed in a better way in some other form at a different cloud. So how do I move? So customers shouldn't be inhibited by those choices. He shouldn't feel that, okay, oh my God, I got stuck here. So you should enable all those choices, right? It's more of enabling the choices for the customers. That's the point. And safeguard the data from external and internal threats. Your architecture should support how do you secure the data. And the last one is automating deployment, which is one of the vision for auto data management, right? And So I'm almost there to conclude my talk, and that's what the OpenSDS is all about, enabling all these data management challenges through this architecture and providing enough plugins and APIs for you to connect to different source of the data, right? And provide those application SLAs in a manner that the business insights or the logics that you wanted to run on them should be easily consumable, right? Okay, just the closing thoughts that so it's all about getting a scalable, standardized for platform to handle the data from multiple sources. That's one of the key thing, and we need to think a little bit different when we talk about data management in the current world because of these different workloads. These are not the same one. They were there from quite some time, but today's world, the compute requirements, the AI, ML have enabled all these dark data, what we call, right? They can crunch this data and get you the new insights. And privacy and security is part of it. We can't ignore that. And OpenSDS is in that direction to solve some of these data management problems, right? So join OpenSDS. And so these are some of the links since SNIA and OpenSDS have a partnership, and some of the links for landing page on OpenSDS, the first one, what's happening there. And it has started recently, and these are some of the initiatives that are happening, but hope more will be there. But if you want to just have a look at this, these are the links. And thanks.